Whoa. Okay, we're going to get started. Just a few things. First of all, they found a white 16 gig iPhone. It's headed to eBay in about 15 minutes if someone doesn't claim it. There's a store around the corner that can do that. Yeah. So, first of all, thanks very much to the social sponsors from last night, Coresight and Dine. Greatly appreciate that. It's great for those of you who are newcomers. Hopefully that helped you find the 15 people that you need to meet that Sylvie spoke about yesterday in the newcomers breakfast. As speaking of breakfast, thanks to MRV for sponsoring this delicious breakfast that we had this morning. And a huge thank you to the speakers from yesterday. I think the content we had was fantastic. We closed it out with a peering track. Thanks very much to everyone who participated, both here in the plenary and split out in the tracks. Today, the track we have is DNS after the close of the plenary. One thing I just want to call out again on the mics, we have the discussion guidelines. It was a little hairy there for a little while yesterday. People could just recognize that the speakers that come up here are doing this on their own time and in some cases on their own dime, and just remember to respect them and respect the people in the audience. It's just greatly appreciated. It causes less friction overall. I would like to invite up VJ Gill and David Schmidt. Are they in the room? There we go. There's VJ. They're going to talk to us about automated configuration and validation of a large-scale network. VJ is ambling up now. You need 4 minutes to talk? 4 minutes early. Your calendar does not scale.
Hello, does this work? Let me try this out. And the reason I want to try this out is A, I'm 4 minutes early, and B, last time I gave a presentation with somebody else's laser pointer was at NANOG 20 in DC, and I shot myself in the eye in front of like 200 of my best friends. So it's vaguely embarrassing. So let me try this out. Pointer works. How do you go? Oh, here we go. Next, back. Excellent. So, hi, I'm Vijay Gill. I work for Microsoft, and we are going to talk about automated configuration management today. This is a very large topic, and this involves a cast of hundreds, although the primary author of the work is actually Mr. Schmidt on my right. So, what is the motivation? Everybody knows, and sorry for the eye chart, it looked a lot better on the 84-inch Windows tablet I do my work on. My bad. So what is the need for configuration management? There's a fairly widespread audience here. How many people here run or operate networks or other large automated systems? For a network operators group, there's not as many hands as I would prefer to see. So what do the rest of you guys do? Drink? Let me try this again. How many people here don't run either networks or other automated or other systems at scale? It's like there's like 2 hands up. So there's a discrepancy here somewhere. Either you guys are still asleep or you're not paying attention. Anyway, so for the problem I'm having is I'm having a hard time reading what's on the monitors here. Good thing I've memorized this entire thing. One of the things everybody knows is that as a network scales, you have to make sure that the supporting systems scale sublinearly. right? I mean, on average, in the G8, you are looking at a loaded FTE cost of about 5 to 4 per $1 million of G&A, right? So as you increase your network size and having your organization scale linearly, your COGS also rises. Everybody here knows what COGS is, right? COGS? COGS is cost of goods sold. It's a large metric. It determines gross margin and net profit. And we're all here to somehow make a profit, except for some who are nonprofit. But point being, you don't want COGS to grow linearly with your service. You want COGS to ideally, or portions of COGS, to track sublinearly with your scale units. And as a result, putting more people to do more work is a losing proposition. Many reasons for configuration management. One of them is scaling. The second one is that it makes it easier to reason about what it is you're doing. And I'll go into stats on the next slide. And the second thing is it enforces standards and it reduces complexity. And one of the things it does, which is very important for us as a service provider, is that it allows us to standardize the network. And with standardization, you can get to scale. And one of the things here is how many people keep documentation in a wiki or a SharePoint, of course, SharePoint, or some sort of other documentation management tool. I see 3, 5, about, oh wow. Because you know what my next question is, how many people here don't keep their documentation around? And nobody raises their hand. Shame on you. The point is, as soon as you put any documentation or any configuration management or any process in a document management system like a wiki or a SharePoint or Jira or whatever it is obsolete. It is obsolete as soon as you hit enter and click on submit or save or save to SharePoint, it's done. It's obsolete. So one of the things configuration management allows us to do is it keeps your documentation as code. Code is documentation. And this is applicable for process, it is applicable for configuration, it is applicable for standards. So therefore, if you change a standard and you change the code, it pushes it out. There's no lag between what you are doing and what your documentation looks like. How many people here love to document stuff they do? All right, at least this time we are being honest here. Exactly.
Does Facebook count as documentation?
Well played, sir. Well played. Well played, Patrick. Well played. The point here is that if documentation is code, then there is no discrepancy between updating your documentation and updating your code, because there are two things. People hate updating documentation for the most part, as you all attested. And second is anytime you type stuff in twice, there is an entry point for errors, for configuration for typos, for configuration creep. So, and humans make mistakes, even engineers. And of course, since we are better humans, that's why Actually, this entire talk is a reason for me to show this picture. Because, I mean, one does think like civil engineers constructing bridges are very rigorous because people's lives are at stake here. They tend to have very large amounts of program management, budgets, and of course, all the ancillary equipment that goes around with building a large sea bridge. You would figure that they of all people would get this right, but obviously not so much. So, moving on. So here are some of the stats. This is why I said it is easier for me to show you, and then we can talk about how to reason or think about how do we operate on this entity. The key part here is there are about 77 to 80 device roles. We don't know for sure because they keep changing around and not all of them are documented in our SharePoints. There's tens of thousands of network devices. Number is very large. I see a bunch of Microsoft people here. You know how big that is and how chaotic, but I should have said that inside voice. There are 30 million lines of config approximately. So now if you look at reasoning about 30 million lines of config. That's one config line. It's about 57 config lines a minute. So about approximately one config line a second. So trying to reason about something that large is just completely not viable by manual or human processing or scanning, right? On the other hand, if we have a generating function and that encapsulates and generates 30 million lines of config, that generating function could be 10,000 lines of code or 5,000 lines of code. And we can reason and think and analyze and check for correctness 10 to 15 to 100,000 lines of code, which is multiple orders of magnitude less than the output that code generates. So therefore, from an inspection, validation, and testing purposes, having automation that can generate 30 million lines of config is much easier to get right, to reason about and think, than to look at the actual raw information that it is generated through that generating function. So that's all good and well, but in the net, people don't care whether what my COGS looks like as long as they get their service at a cheap or acceptable price. So in the net, all we are trying to do here is make sure that what we are doing is actually resulting in good service management, because customers care about reliability, data loss, and so reasoning about how to give them that using a large system, and we are working on large systems now. There's no longer like networks or computers or data centers. It's all one integrated system. It requires very rigorous service management. It allows us to reduce cost. Already talked about COGS on an SG&A perspective. It's great for users. It gives them reliable service without manually triggered outages. Although if you've been reading the press lately, we are not quite, I think, as an industry where we need to be. And it improves time to market. You can't reason about 70 million lines of code or 30 million lines of code and then make changes, operational transforms to get you from one service offering to another service offering, but you can reason about code that operationally transforms this service offering with that 30 million lines of code to this service offering with that 30 million line of code. Because here, you're operating on 10,000 lines of code. I can understand 10,000 lines of code. I can understand 30 million lines of config. At least I can't. Most people here, I guess, can, but that's why you're smarter than I am. So how did we do this? Well, when I say we, I mean David did this. I'm only the mouthpiece. Work and credit should be given to David and a lot of the people here who are writing plugin scripts, and David will go into how that's implemented. So one of the things we did was I set a principle out that in 2 years, there should be no human touch on the network, except for very urgent break fix. And having that as an operating principle or an overriding goal then allows us to work back and like reason about how do we get from where we are today to where we want to be. And so Microsoft, like our friends, is Edward here? Edward Crabb? Here he is. Much like as Edward gave in his talk yesterday, and there are two networks. One is the internet backbone, and then there is the data center to data center backbone. And one of the goals we set out for the data center backbone was that it should be entirely 100% automated. And David will go into more examples there. And it's inspired by other programs on Microsoft. If you Bing for Autopilot, Microsoft, the first hit is a paper by Microsoft Research that talks about the Autopilot Fabric Configurator. The second one is the Azure Fabric Controller. So if you Bing for that you'll also see a write-up for that, which is pretty open, I guess, in the industry. So we are trying to move the industry forward by publishing some of the work that Microsoft Research and some of our business groups have done. The thing I was trying to point out here is that we are now at a scale where we humanly can't do this. It's not possible on a manual inspection or manual work to actually get to where we need to be. There are services here at Microsoft that don't boot up short of like 20, 30,000 servers at a time. That's like the minimum footprint for a service to come up. And I can't, at least I don't know anybody else who can manually configure any element that takes care of like 30, 40, 50,000, 100,000 hosts at a time. It's just too large to do by hand. And of course, one of the problems is that at that scale, you are constantly broken. Failure is rampant at all points just by the law of large numbers. And so therefore, as you, at that scale, there's so much failure that if you have to manually remediate that failure, you would have like 10,000 people just sitting there, like 10 people per tour, to figure out what's going wrong. I see Dylan is here. He's like, I do that, Vijay, stop lying. But you see where I'm going with this. Just think about the numbers. And of course, it follows the light-out management principle, which is to reduce SG&A. So here are some of the stats we've seen. So the first stat is, about a year ago, it took us about 2 to 3 days to roll out a router. After the automation was in place, it's about 30 seconds, and most of that is getting your credentials in. It took about 2 to 3 engineers to do peer reviews, checks, and all the other associated process to turn something up for network acceptance. Now it's 1 engineer, and that's mostly typing your credentials in. And of course, even our engineers were making 10 to 15% error rate compared to base config. These stats are derived from checking what was bounced back through peer review, and after there's 0%. The bill of wrongs is a system that we keep that notes exceptions, and every router would have, like, we would discover in the network 4 to 6 items that would go into the bill of wrongs. After automation, they're 0 because, well, you either coded in the documentation and so you don't need a bill of wrongs, or it doesn't make the mistake so you don't need a bill of wrongs. So either way, bill of wrongs is now being rapidly cut down. And change velocity. Just from the sheer amount of process and human inspection, we could push about 50 changes on a certain segment of the network a month. Now we are pushing, I think it's 1,300 now? How much? Oh, it's out of date. We are now pushing 2,000 changes a month into the configuration. And there are some issues with that, and I'll get to it in a second here. But basically, this kind of shows the amount of goodness that we managed to leverage. And to do that, there are certain principles that we adhere to when designing the system. The first principle is deployment is declarative. You declare what the state, that the desired state is, and then the operational transforms looks at desired state, current state, and does a minimally invasive set of procedures that takes it from current state to desired state. So it's declarative deployment. I already said we had a principle that said no human changes on the network, and by declarative programming, we can make sure that that happens. And there should be never any end user downtime during deployments. That is more of a platonic ideal, because everybody knows our friendly bug-filled routers, even with the most rigorous testing, some still escape in the field. So we would like to be there, but in some cases we are not. But we are minimizing those, and we are a lot less than when we were doing it by hand. One of the things here is that we can now repair automatically. I talked about it a little bit. At the scale we are operating under, when I say we, I mean the generic industry is moving to, you can't repair things by hand. You have no time to inspect, test, validate, and then issue a repair order. It has to be done automatically, kicking the RMA off, bringing the stuff in. And of course, keep repair simple. In an ideal world, if you have large enough scale systems, you can turn the network or the managed elements off, and the applications will be able to deal with it. So if you have a large, like assume, like let's work this mental exercise. Let's take a cluster with 100,000 systems. Out of that system, over a month, hundreds of disk drives will die. There will be tens of TOR failures. There will be hundreds of link failures. If your application is designed to run on that system, it can deal with network failure, which is the purpose of this particular automation, the same way as it deals with a host failure. Because From the application perspective, if you are running across a bunch of servers and the far side server goes down, or an element goes down in the middle that allows this server to communicate with that server, it is indistinguishable from a host failure. A network failure is indistinguishable from a host failure because an unreachable host is an unreachable host regardless of whether a disk drive failed, you had a CPU hard error, or an element that connected you to that host, the network in between you and the host, failed. So at that point, the application itself is designed to deal with host failures, and for free, you get network failures in the fabric. And now that's not 100% true for gray failures where, from a network perspective, sometimes it's hard to distinguish between hard down and soft corruption, so on and so forth. But for the vast majority of cases, an application looks at a network failure as a host failure. And that allows it to mitigate the service away by moving it to a different set of hosts. And then you can kick off your repair process at leisure. So this allows you, for example, to move away from a 4-hour replacement window, which is very expensive, to maybe 1 week replacement window, which is significantly cheaper from a MNR perspective. And MNR, of course, is directly flowing through to COGS. Alarming. If you can detect a problem and you can alarm a problem, you know something is wrong. And since we are in a declarative policy system, if you know what is wrong, you know what you need to do to fix it. So repair becomes the same as alarming, or alarming becomes the same as repair, or vice versa. Again, there are some nuances here that because of time I'm not going to go into. Follow up with me outside. But for the high level, you can think of alarming and repair as two sides of the same coin in a declarative system. And of course, software development life cycle. Microsoft is a software development company, and applying the same SDLC principles to network as we do to Windows or Office or to other products actually maps very well. In the net, and I've told my guys this, I'm not looking to hire network engineers anymore. I'm looking to hire software engineers, because this is now in all ways and forms a software system. It is I don't need quote unquote router jockeys. I need people who understand, can reason about systems and programs and code and unit tests, and we'll get to that in the next slide. This is an area where there is still a lot of room we have to work on. So again, like I said, it is easy for us to reason about 10,000 lines of code versus 30 million lines of config, right? You can think about it, but still people make mistakes, errors come in, data quality issues, transposition of IP addresses. So one of the things that we are working on now is we can test and validate the program, the generating functions that generate our config, but there's also another software test system, and David will go into that a little bit in his portion of the talk, where we are looking at how do we unit test two things. You unit test the output of the programs, and then you unit test the programs themselves. So an example, we have a router which needs a loopback address. So you run a unit test on the module that generates the loopback config, but one of the things that you can do is that we know that the loopback address should have two properties. First property is that it should come from a assigned block of loopback addresses. So you run a /32 or a /128 match against the reserved block of loopback addresses and see if it fits into that. The second property is that it should not be assigned elsewhere on the network, right? And of course, that is again easy to test for. You run a grep or you run some sort of other check against what's already in the network and see if both those properties hold true. If both those properties hold true, it is much safer to push out that config and know at least that we are not going to bollock something majorly up, because the worst case is that we assign a loopback address that is on the far side or on the near side when it shouldn't be, but we know that it's not going to conflict and cause ISIS recalcs, and we know that it's not going to blow up an ACL, because in the ACLs we know that loopback addresses should be denied, or whatever it is the policy is for the ACL. So we feel that within the guardrails of the of the unit tests that the output of this program is now valid for deployment into the network. And that's an area we are still working on. We know what the end state looks like, and I described it. We are not fully there yet, in interest of full disclosure. But again, just reducing the entire configuration to generating functions that are several thousand lines in code allows us to be much more manually rigorous in inspection with the output. We've so far haven't managed to blow up anything major via automation. And of course, one of the last principles is standardization. By definition, if you're coding out and you're spitting a small generating function that explodes out to hundreds of thousands of lines of code, you have to have standardization, because you need a very few elements, because you can reason and think about those few elements and then replicatively apply them. It's like fractals. Most people here are familiar with the fractals. The generating function for fractals are like, in some cases, a couple of lines of code. The equation is like single line of code. One of the simplest fraction is a squared is equal to c minus z squared plus a constant. But if you look at a fractal, there's a lot of information, there's a lot of density in the output. You can reason about the generating function for fractal easily because it's literally like 5 or 6 bytes of information, versus the output, which by definition is essentially infinite. Same way, from our purposes, the minimum amount of generating functions we have, the simpler and easier it is to reason about correctness in the network, and which forces standardization. And with that, I hand it over to Mr. Schmidt.
Which way is forward? There we go. Hi, my name is David Schmidt. I work with the core network engineering team with Microsoft. And the system that we developed was designed to do a number of things, minimizing cruft, identifying and removing any bits of leftover code that was unnecessary to the operation of the network. Anytime a design update is needed to push it out, the core, for example, is made up of approximately 180 design elements, and on occasion those elements need to be updated. As we do maintenance, verifying the output, verifying the conclusion of the maintenance is critical. Are we sure that standards have been met? Are we sure that the network is going to run as designed after we conclude a maintenance? The less variation there is in the network, the easier it is to support. This adds to operational simplicity. If the router is predictable in its function, is predictable in how it's configured, it is very easy to support and troubleshoot when there is a problem. At Microsoft, we have many hands in the network. It's very easy for those many hands to come up with many ways of doing things. And when that happens, accuracy goes downhill. So we needed a single way of deploying changes to the network. And that adds to the efficiency. When there's many ways of doing things, efficiency also declines. The approach we took was to break down the configuration and standards into little elements. When you have little pieces of code, it's easy to verify that those pieces of code match to the standard. It's also very easy to come up with a remediation action when they do not match. For example, we have a snippet. There's 6 different elements identified here. As for the individual scripts themselves, logically they're broken down into sections. The scripts are templated in such a way that non-scripters can easily modify these elements. The libraries, for example, are separated off so that it keeps the individual scripts very lightweight. The scope identifies what routers or devices this script applies to. This can be done via database mechanism, pattern match on the name, or whatever other mechanism would identify a specific router that this script applies to. Dependencies I will talk about later. The expected state is the standard you're comparing your network against. This can be hard-coded into the script. It can be pulled from an external source. it can be dynamically generated by the script itself. The conditions are the flexibility by which the script will pattern match the expected to the actual state of the config. This is an important component of the overall system, and I'll talk about this later. The user options define what the action is that the script is required to take, whether to generate a change and push it out to the network, or to just simply report on, here is a failure and what you need to do to fix it. The actual configuration is more or less a pattern match against the configuration of the device that we're looking at. Finally, the script will compare the actual to the expected. If it doesn't match, then it moves on to the output, which is generate a report or push a remediation action. As I mentioned earlier, the libraries are very important to keep the scripts lightweight. A typical script is only about 60 lines long. This, again, allows non-scripters to be able to go in there and tweak them when a change is necessary. This is an example workflow. So, for example, we have a device configuration. The various components are monitored by individual scripts. For example, the interfaces, there is a problem, and based on the user option, there's a report or repair action, and the repair goes back and fixes the incorrect item. Conditions, as I mentioned earlier, this is very important. We have various pattern matching auditing tools today. They unfortunately generate a lot of false positives due to the inflexibility of the pattern match. There's oftentimes many ways of doing something, and a pattern match can be very rigid at times. So the example here, we have two prefix lists. At first glance, they do not match. However, under the loose match rules, everything is accounted for, and this particular configuration would pass. However, under strict rules, there's one line in particular that does not belong and should be removed. And then finally, we have strict order, which requires the expected configuration to exactly match line by line in order to the actual configuration. And the remediation would be to remove the prefix list entirely and re-add it in the expected order. Dependencies. Since we broke down the configs into very small pieces, oftentimes there's one script that monitors one part of the config, while there's another piece of config somewhere else that is perhaps broken, and one script is unaware of the other. So we built in a way for scripts to recursively check other scripts to see that other components are also passing. So the example I gave, a peer group has dependencies on BGP policies. BGP policies have dependencies on prefix lists and AS paths. So if there was an issue in the AS path, for example, the peer group, when I ran it, or would run it, would fail and would identify the dependency as the failure. The initial deployment, we wrote approximately 230 scripts across 4 device roles in our core and edge routers. As I mentioned earlier, an average script ran about 60 lines. We found across those 230 scripts about 4,000 different variations that we needed to remediate. Some of these variations were very simple, description issues, extra cruft, not a big deal. A few of them we looked at and wondered why we weren't bit by them earlier. Challenges. So one of the biggest challenges is different vendors and how their configurations are formatted, how the behavior of the router is when you make a change. You can move from, with one vendor loading a config and saving it and you're okay, whereas another vendor removing a prefix list, for example, might be a problem, and re-adding it may have a brief period where there's issues on the router. We're looking into netconf to solve some of these issues, but we're not quite there yet. During the initial cleanup, we found we had to do a lot of research into why things are. Simply going from the current running state to the standard state was not always the best choice. Doing so could lead to outages, so the cleanup process was time consuming and difficult. Scripts can conflict with each other. So for example, if you have two scripts that are both looking at the same portion of code and they want to do something different, they can both, or one or the other, fail. So you need to be careful to limit how the scripts are monitoring your configurations. And then finally, script coverage is really important to achieve maximum benefit. For example, if you only are monitoring half of your configuration, how do you know if there's cruft lingering in your other half of your configuration? So by covering the entire code, you can quickly identify what doesn't belong and what is left out of the framework. As far as other use cases, we use it for a config generator. With just a few variable inputs, we can generate a baseline template for a new router. As Vijay mentioned, it takes just seconds to do and has greatly diminished the number of errors in new router deployments. We're also using the framework, the same libraries, to do incremental changes. For example, new peering sessions, new interface turnups are tailored so that they take user input, and the user input creates an expected config, compares it against the router, fails, generates the remediation, and we push it out to the routers. Thank you. Are there any questions?
Hi there. So obviously, you know, these are networks. Sorry,
Name and
Edward Crab, Google. These are networks. These devices interact, and you're going to have changes that encompass multiple devices. Do you have some transactional semantics to take care of partial config changes across the network that are actually related to each other? Do you just roll back all of them, and then how do you deal with the different levels of push that you may have for a given transaction across multiple devices?
I can get it. So one example was updating a MD5 password on our LDP sessions. Obviously, you have to have the same password on both sides. So if you have one router updated, the session will be down until the other side is updated. We have the ability to push out all the configs within a few seconds by doing parallel streams with these scripts. Most of the time that's not necessary. We just push out one at a time as necessary.
I'm not really talking about speed of delivery, though. I'm talking about when one of the pushes fails, right? So you have to keep track of state on multiple devices to determine whether the scripts have completed for the complete set of devices.
Oh,
and
correct.
And if the complete configuration of the network is clean and, you know, not marked dirty anymore, rather than an individual device or scripts partitioned config portion of a device.
Okay, so after the scripts are run, all the changes are pushed, we can rerun the same script with a different option to report out what is still failing. And if it comes back, everything passes, then we're done.
If you're looking for atomicity, transactional atomicity, no, we don't have transactional atomicity yet. I'm looking at you, though. We'll fix it.
Hey, Todd Underwood, Google. I think this is a question for Vijay because it's not about the structure of the configuration management system, but it's about the cultural issue. You said you're looking to hire software engineers, not network engineers. And I assume that's because one of the biggest problems that network engineering shops have with automating network engineering is that it puts network engineers out of business, and it's a very different job that needs to be done. How do you deal with that? Like, there's a core of people, I mean, there are people here who have been ranting about this for, you know, a couple decades campaigns now about monkeys on keyboards, but like in reality, there's still a lot of monkeys on keyboards, and lots of us feel better when we type things in. We feel like we're doing something. And even though we know that's wrong, like that's the wrong way to do something, but we feel like we're doing something. How do you deal with that?
Okay, so did everybody get the question? The question was, and if I can summarize it, was basically that a lot of people feel that automation will take them out of a job, and some of us just feel better when we type stuff in. So how do you reconcile all of those? So if you want to pull back a little bit and think about the STEM production of engineers, right? The STEM production in the US is much more heavily tailored towards CS as opposed to network engineering specialties. In fact, most places don't have network engineering specialties. So if I just look back 5, 10 years going forward into where the networks and systems, like I mentioned earlier, are evolving to, by definition, I need to go where the engineers are, right? It's like, why do you rob banks? I rob banks because that's where the money is. And so now I'm going to tailor my systems to go to where the money is. And in this case, the money is in engineering. And in engineering, the vast majority of people that are relevant to this industry are coming out of software engineering CS degrees.
Oh, sorry. Right? I think this is exactly the right thing to do, and
No,
that's one good reason. But the question is, how do you sell it?
I'm getting there.
All right.
Right? So the first part is that by definition, I have to go to software engineering anyway. Right? So the second part is then how do you transition our existing base while keeping the system running into a software-centric culture? So there are two things that work here. The first principle is that, as you are well aware, and so is Edward, these systems are too large to reason, think, or even type stuff in by hand anymore, so there's no other fucking option. Did I say that? So that's one. By definition, you can't just do it. The second part is that this is not really a role removal. I'm hiring my team essentially by, I'm doubling the size of my team this fiscal year, which starts now, in 3 weeks. I'm doubling the team because I don't need highly paid, high GNA folks to type stuff into routers. It's not a good use of their time. B, I need them to start thinking and reasoning about design goals, about operating principles, so they can feed back stuff to coders. Even within the coding community, it's not like one giant amorphous blob of coders, right? There are people that want to do testing, there are people that want to do new features, there are people that are very good at doing maintenance, right? So even within the network engineering field, it's not a blob of network engineers that type stuff into routers. Those are the people that are spending time typing stuff in, where I would rather have them spend time thinking about other things, like how do I do a design? How do I do a regional routing system as I expand to emerging markets? How do I think about that? How do I operationalize and implement scripting? How do I make my RMA process more efficient? I want them to think more high-level design, not type stuff in. And most people who are good, and the ones that you want to keep anyway, are bored and don't want to type into routers for the most part. So that actually dovetails very well in. And there's always going to be people, and there's always going to be need from a break fix and an operational perspective of turn-ups or base configs who want to do stuff on routers. Unfortunately, that is a requirement in some ways and will continue to be, but that's in my thinking, that's a career-limited role.
Thanks.
Anton Capella, 5'9", no one else? Warren, I'll defer to Warren here, please. Okay, thank you. What do you think is the future of this area that you're working on in respects to SDN networking that's, call it non-traditional? I'm assuming right now the target is pushing things into existing disparate boxes. Maybe that's changing. Is this something you're thinking about in terms of a completely broad sense, generic abstractive networking configuration? Or is this specifically working on right now things that we would think of as traditional routers with consoles and the problems that come with that?
So in general, this is a context or a cultural shift. What it operates on is in some ways completely orthogonal to the problem. What we're doing here is semantic development. What it operates on is syntactic sugar. Whether it operates on a Juniper or a Cisco or a Alcatel-Lucent or whatever is syntactic sugar and is irrelevant to the larger principles at work here. So whether it operates on a SDN type network is almost in one, I would argue, is not really relevant, except to the point where Edward was talking about, because that is more closely coupled than what we have today. This is what Dave was saying, that some of the syntax input or CLI exposure lends itself to some problems. For example, with consistency, with effects. What Edward was talking about yesterday is actually a very good system where you can think about the entire unit as a single entity and operate on it in different fashion, but the principles are still the same. It's the implementation that's a little different, and there are some deltas with transactional consistency, which are easier to deal with in what the SDN type workflow is versus our current piecemeal unit at a time, current state of the routing art. And that's